Good evening, students. Today we will discuss about the linear programming problem. So actually, the linear programming problem deals with the complex problem, or in the operation research. Here we can use the concept linear programming problem, but the operation research is nothing but we have to solve any kind of problem or complex problem by using the operation research concept, right? So now we can go for our slide. So operation research is a branch of mathematics, especially applied in mathematics. So the general approach is to analyze the problem in economic terms and they implement the solution if it does not aggressive or violent to other aspects like human, social, and political constraint. Generally, this is a situation here we have to use the operations research to solve the complex problem. So this is a general definition for this OR. The operation research is the art of giving bad answer to the problem where otherwise worse answers are given. So this definition is given by T.L. Sati. This definition covers one aspect of decision making, that is choosing the best alternative among the list of available alternatives. So this is the general form of the LPP, linear programming problem. So first we should know the basic things, that means the general form of the LPP. In the general form of the LPP, the first one is objective function. So the objective function is nothing but it should be optimum. Optimum means whether it is maximum or minimum. Therefore, the objective function is whether it is maximized type or minimized type. Therefore, z equal to some c1x1 plus c2x2 plus c3x3 plus etc. plus cnx1. Subject to the constraint. Second one is constraint. That means subject to the constraint. Here we have m number of constraint. Yes. The general form of the LPP is the first one is subjective function. The second one is subject to the constraint. And also the last one is inequality condition. So in the objective function, we can represent the type whether it is maximum or minimum. That means maximum means maximize z equal to some c1x1 plus c2x2 plus c3x3 plus etc. plus cnxn. Constraint means here we have m number of constraints like a11x1 plus a12x2 plus etc. plus a1nxn. It is less than or equal to or greater than or equal to or it is equal to some b1. So in the similar way, here we can represent the second constraint like here a21x1 plus a22x2 plus a23x3 plus etc. plus a2nxn. It is less than or equal to or greater than or equal to some b2. Up to the mth constraint, that means a m1x1 plus a m2x2 plus etc. plus a mnxn, it is less than or equal to or greater than or equal to some bm. So this is a general form of the LPP. So the next one is some simple example to formulate the LPP. So to formulate the LPP, they will give some problem. For the given problem, we have to formulate or we have to represent the linear programming problem. Suppose if you have to solve the linear programming problem, means you can solve any one of the given method like graphical or simplex or bigger method to solve the LPP, right? Now, see this example. Here we have some ABC. Here ABC means articles, 3 articles ABC. And the corresponding weight, volume, and the cost values are given. So with this, we have to represent we have to formulate the LPP. So first of all, you have to represent the objective function. The objective function, it may be maximum or minimum. You have to check. See this last line. Find the number of articles to be selected from each type such that the total cost is maximum. Suppose if the total cost is maximum means this is the maximize type. Therefore, here you can write maximize is equal to what about the cost value or what about the profit value. Here you have to represent the profit value in the objective function. Suppose here 5, 6, 3 means here you have to represent 5x1, 6x2 and 3x3. So this is for the Z value, that means maximize Z. Therefore, maximize Z or maximize T equal to 5x1 plus 6x2 plus 3x3. So next you have to represent the constraint. Already we know the general form of the linear programming problem. We have m number of constraints, but in this case, the first constraint is 4x1 plus 8x2 because the weight values are first constraint. We have to assume the weight values are the first constraint. Therefore, 4x1 plus 8x2 plus 2x3. Similarly, the second constraint is the volume. That means 9x1 plus 7x2 plus 4x3. So finally, you have to represent the objective function constraint and also the condition. Condition means all the variable, it should be greater than or equal to 0. So this is the general form of the LPP, right? So the next one is a graphical method. Suppose here we have, if we have the linear programming problem, we have to solve the linear programming problem by using whether it is a graphical method or simplex method or a bigger method. So first we have the procedure to solve the given LPP by using graphical method. Here we have some step-by-step procedure. So the first step is plot the graph corresponding to the given constraint. The second step is determine the region for the given constraint. Similarly, the third step is determine the feasible region. Fourth step is determine corner extreme points. The last one is examine the corner or extreme points. So next we have some basic definition. That means the slack variable, surplus variable, and also the artificial variable. Suppose if we having the constraint is less than or equal to type, we have to add slack variable. So in the another way, suppose if we having the greater than or equal to constraint, you have to add surplus variable with artificial variable. And also suppose if you are having equal to type means here you have to use or you should use only artificial variable. So we have some procedures or we have some definitions for the slack variable, surplus variable, and also the artificial variable. So the next one is simplex method. So to solve the given LPP by using, here we can use graphical or simplex or bigger. So we have some procedure to solve the given problem by using simplex. This is step 1. Convert the LPP into the standard form by adding slack variable. So this is the step 1 or first step. So in the second step, construct the initial simplex table. Initial simplex table. So the next one is we have to test the optimality. We have to test the optimality. That means Cij minus Zij. It is less than or equal to 0 or equal to 0 or greater than or equal to 0. So we have to test the optimality value. So the next one is select the incoming variable to enter the basis. Select the incoming variable to enter the basis. So the next one is test for the feasibility variable to leave the basis. And also the last two steps are finding the new solution and also repeat the procedure to get the optimal solution. So these are the basic steps to solve the given problem by using simplex method. So I think this is enough for this class. So I hope you are all having the basics of the linear programming problem in this session. So thank you very much.